Hi, this presentation is going to help you with inequalities. Anytime you write a list like 13, 14, 15, and then dot, 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 we're going to talk about how you write an inequality out of that. And if you're trying to figure out how to write these compound inequalities with double less than signs or greater than signs, we're going to cover that too. But we're going to start out with the real basics. What does 2 is less than 8 mean? So we read it as 2 is less than 8. And what that means is that the 2 is smaller than the 8, and the mouth is eating the larger number. That's how I remember it. So we can think about a crocodile or an alligator eating the larger number, which is 8 in this case, and the point is pointing to the smaller number. You should also be able to read inequalities both ways around. So even though we read this as 2 is less than 8, it's the same thing as 8 is greater than 2. You should be able to think of it in both directions. So now let's talk about 8 is less than x. What does that mean? It means that you can take the x there and place a number in for x instead of x, like 2. That would make it true. 3 would also make this inequality true. So lots of other numbers could go in for x, and x is less than 8 would still be true. So I could put a 1 in there, I could put a 4 in there, a 5, a 6, a 7. X is less than 8 is all the numbers that you can put in for x and have the statement still be true. Even decimals and fractions are allowed. So 1.2 is less than 8. 7.99 is less than 8. And there's our fraction, a half is less than 8. And negative numbers are allowed too. So -5 is less than 8. All of those numbers can go in for x to make the statement true. So we can show that in algebra. We used to, if you remember how to do this, show it by shading the numbers that are less than 8. And that's a good way to show that x is less than 8 is all of those numbers less than 8. It could be any of those numbers. In set theory, we list all the numbers less than 8. If we're just thinking of integers, positive and negative whole numbers, then we'll write our list like this, with a dot, dot, dot on the left side to indicate that the numbers keep getting smaller on the left, that you could go to -2, -3, all of those little negative numbers. But on the right-hand side, they stop at 7, since 7 is the last whole number or integer less than 8. If we're thinking of just natural counting numbers, those are the numbers that kids count on their fingers, then we would write 1, 2, 3, 4, 5, 6, 7, since the natural numbers start at 1. That's your first finger, 1. But if you're thinking of all kinds of numbers, every possible kind of number, then it's impossible to list. You would have numbers lower than -1, that's the dot, dot, dot on the left, but then all the numbers in between every single number. So in between 1 and 2, here's 1, here's 2, you have all of those decimals and fractions. And so actually it's an infinite list and it's impossible to list. So each different kind of list that I mentioned is written differently in set notation. There's this one with just the integers. We write x is less than 8, and x is an element of the integers, and use I for integers. Sometimes some textbooks use z for integers, but we'll just use I. It's a little more simple to remember. And this list that starts with 1 and goes 2, 3, 4, 5, 6, 7 is just natural numbers, so we write the set of all x such that x is less than 8 and x is a natural number. So here's the set of all x such that, and then x is less than 8, and x is an element of the natural numbers. X is a natural number, or a counting number. And then the list of all the numbers less than 8, the one that it was impossible to list, it is possible to at least write it symbolically. We just write the set of all x such that, this line is such that x is less than 8. And that's it. No restrictions. So how do we show x is greater than 12 using lists and set notation? If we're thinking just of integers, what would our list be and how would we describe it? If we're thinking of natural counting numbers, what would our list be and how would we describe it? What about all numbers? What would our list be and how would we describe it in set notation? So this is two different things. The first thing is a list and the second thing is the description of it in set notation. See if you can try it before I show you the answers. So go back here, try this on your own and see if you can figure out each one now. Pause the video. And now the list of integers greater than 12 would be 13, 14, 15, 16, ... on the right, indicating it keeps going higher after 16. And so we would write x is greater than 12, and x is an element of the integers. The natural or counting numbers greater than 12 is actually the same list, because there are no negative numbers. So it's still 13, 14, 15, 16, ... on the right, indicating we keep going. And we would write x is an element of n instead of I. But it doesn't make any difference to this list. So either way of writing this is correct. All the numbers greater than 12 would be impossible to list. So we would only be able to write it like this in set notation. How about this one, 9, 10, 11? These are natural counting numbers, 9, 10, 11, you can count on your fingers, that are greater than 8 and less than 12, right? Because 9 is greater than 8, 10 is greater than 8, 11 is greater than 8, but we want it to stop there, so we note that they're less than 12. So let's translate this. Translates as natural numbers, counting numbers. We have to say x is an element of the natural numbers or counting numbers greater than 8, x is greater than 8, and less than 12. And there you go. If you just put that together, you're fine. But we can write it as x is greater than 8 and x is less than 12 and x is an element of n. But if you want to write it more compactly, you can do this compound inequality thing, which I will take apart and explain piece by piece now. So here we go. How do you get from there, x is greater than 8 and less than 12, to this really incredible tiny compound inequality? So let's pick it apart. Think of these things. You're going to be putting the x in the middle between the 8 and the 12. And then you're just going to have to figure out how to point the inequalities in the right direction. So we still want the mouth to be eating the larger number, and this is where being able to think backwards and forwards about this is important. Here's our x greater than 8, but that also means that 8 is smaller than x. So we want to take the 8 here and say that it's smaller than x, and you'd still have x is greater than 8 if we read it backwards. So the mouth is eating the x, not the 8. Because x is the larger number. The other thing you've got to think about is that since x is less than 12, if we take out the x in the middle, it should read correctly as x is less than 12. And that's how you know you have everything pointing in the right direction. So what about less than or equal to and greater than or equal to? You can use those instead of less than and greater than in a lot of these things that we just went through. The only difference is that now when you put numbers in, 2 is less than or equal to 8, 3 is less than or equal to 8, you could put 8 in here and the statement would still be true. So all the same numbers as before and there. That's still true if I put an 8 in there. So that means we're allowed to go all the way up to and including 8 when we use less than or equal to 8. So our list now goes from 1 all the way up to 8 and includes 8 if we have x is less than or equal to 8. And if we have x is greater than or equal to 4, then we would include the 4, and it would be from 4 on up. And if we had a compound inequality, the one we had before, 9, 10, 11, we could write that as 9 is less than or equal to x, which is less than or equal to 11. And that's a little easier sometimes because it includes both the beginning number and the end number that way. So now you try this set of different problems. Here's my list of these guys that I want you to try. See if you can write each of these as an inequality in set notation. That means that you would be writing the set of all x such that, and then write the inequality symbol and write whether x is in n or in I, or if you don't need a restriction. So pause the video and try this out before you look at the numbers, before you look at the answers. Okay, here we go. So take a minute to look and see if your answers matched mine here. So I pointed out that in most of these cases you could use I instead of N and it doesn't matter. Except for the bottom case, you can only use I, not N, because we have these negative numbers. So you have to say it's a part of the integers. Counting numbers are not negative. Kids don't count negative numbers on their fingers. And so you have a bunch of different choices for how you can put it. If you didn't try this out on your own, go back and try it out on your own again and come back to this slide and then take a look at the answers. And then that's it. If you need more help, remember you can just ask. Bye.